Hey everyone, in this video we're going to talk about functions a little bit more by talking about domain and range. So you should be able to define domain and range and express them in interval and set notation, which is why we learned that in the last video. Now domain and range will help us describe functions because domain and range tell us where a function lives. So let me be a little bit more specific here. Okay, when we talk about domain, we're talking about what x values are included on a graph or in an equation or in a function, etc., etc. And when we talk about range, we're talking about the y values. Okay, to be more specific with domain, domain is all, or actually let's be even more specific than that. It's the set of all inputs in the function. Notice I use the word set, which is why we describe it with interval and set notation. And when we talk about inputs, we're talking about x values. Whereas range is the set of all y values for that function, or included in that function. And we're not going to use what, we're going to keep it consistent. Outputs. Okay, and when I say the set of all inputs, essentially what you're just saying is what x values are a part of the function. And this will make more sense when I give examples. Whereas you guessed it, range then is what y values are included in the function. This may be easier to understand with a graph. So I'm just going to sketch a quick graph. I'll pause the video and do it, and then make sure you sketch it in your own paper. Cool. I just sketched a quick arbitrary graph. It's not like linear or quadratic or anything, just so we can have a conversation about domain and range without worrying about that. So domain, again, is the all possible inputs to the graph. And when we talk about inputs or domain, we're talking about, again, your x values. Whereas range, we're talking about your y values. So when I'm asking you what the domain of this graph is, I'm asking where does the graph live in terms of x values, or on the x-axis, or what x values are represented here. Okay, so as a reminder, this is the x-axis. Okay, so when I'm looking at what x values are included, I would say like, oh, -5 is included because here's where x is -5. Or 2 is included, right, because this is the point 2, 0, so that lives on this graph. Okay. Now, I like to draw boundary lines of where the lowest x value is. So it stops right here. Doesn't go past -6. Doesn't go this way at all. So that tells us something about our domain. And then as I go this way, like all these points will be included. -1 is part of this graph. Like a half is part of this graph. 3 is part of this graph. And then this goes on and on and on for forever. So this would go towards infinity. So if I'm talking about the domain, and I personally like interval notation, remembering that that's like your lowest bound and then your highest point or number in that set. Okay, the lowest thing x can be on this particular graph is -6, right? It doesn't go past this point because it just stops right there. The highest point on x, if this continued forever and ever and ever, is infinity, because that arrow will kind of cover everything. And as you can see on -6, that point is included. So we want -6 to be a part of our domain, and to include that, we would draw a bracket. And then on the infinity is the highest point. We always throw parentheses around that because infinite is not a number we can like include. It's a concept. Okay, so that's how you would write the domain of this graph in interval notation. Now the range, we're going to do the same thing, but instead of looking at the x values, we're looking at the y-axis here. So y values are up and down. So like this is a y value. That's the lowest one on this graph. It's the lowest y value goes. So here's my boundary line. Okay, the highest y value, some of you might be looking at this point over here, but you can't forget that that arrow's over here, and this is going to go on forever and ever and ever and get increasingly taller to infinity. So therefore, the highest y value is going to be infinity as well. And the lowest one then, well, this is the point -4, -4, which makes the lowest y value -4. And because there is a point right there, that's included in our range. And since the highest y value is infinity, we put a parenthesis on that. Okay, just a little tidbit of information. You may see some examples that aren't included, which is why I made sure to mention that. So let's say it looked like this, and you had an open circle there. Just like on a number line, you wouldn't include that value. So instead of this being a bracket, that would be a parenthesis. Okay, so it just depends on what you have in your graph. I filled that in, so that is part of our domain. Just for fun, I want to practice converting these to set notation. So what I'm going to do is I'm going to pause the video, and I want you to try converting each of these to set notation, and then I'll come back with the answer. Okay, here's what I got just for some practice. Remember, you always have the curly brackets in set notation. You always define your variable first. And this is where that definition comes in handy, because X talks about domain. I called this X. Y is range. I called this Y. And the inequality to describe the domain is I want everything from -6 to infinity. So I have X being greater than or equal to -6. And it goes on forever and ever. Same thing with range, but the lower bound is -4. Okay, let me know if you have questions on that conversion. Just good practice. Little bit more difficult when you have an equation and not a graph. I'm not going to lie, but we can do it together. I believe in us. So remember, domain is all possible inputs in the function. So I'm looking for what can I input or plug in for X. Now, sometimes because there's infinitely many things that might be on a graph, it's easier to think about, is there anything that X cannot be for the domain? So the easiest way, in my opinion, to work that out is to just try plugging things in. So let's say I plug in 1. Is that going to work? Well, 1 squared plus 5, that's 1 plus 5 is 6. That works. 10 squared is going to be 100 plus 5. That works. And you might be thinking to yourself, like, wait, what wouldn't work? So I'm going to jump down to this example to kind of show you here. Let's say I plug in -3 for this function. My input into X is -3. That would be a +3. What would you get? Then you'd have 4 divided by 0. Can you divide something by 0? Go ahead and try plugging it in your calculator. You should get an error. Why is that? Hey, when you divide something by 0, think about like cookies. I always talk about cookies. You have 4 cookies and you divide them into 0 parts. Does that make sense? No, because you have at least 1 part because you have the cookies. Unless you make them explode, but we're not going to talk about that for now. So you can't divide something into 0 parts ever. Okay, so that would cause a problem for our domain. So the domain of this could not include -3 because it answers the question, is there anything X cannot be? I'll come back to this problem in a second, but I want to keep talking about this one. So is there anything X cannot be here? Can I square a negative number? Yeah, I can. That works. Can I square a fraction or a decimal? 1/2 squared is just 1/2 times 1/2. Yeah, that works. So in a quadratic situation, there's nothing that's going to give you an error. In fact, when you're looking for domain and you're looking for things that X cannot be, you want to look for dividing by 0, because you can never divide by 0. Another thing that will come up is you can't take the square root of a negative number. I'm not going to talk about that too much yet, but try taking the square root of -9 in your calculator, see what happens, and see if you can answer why that won't work. Feel free to ask me about it, but it'll come up later in this class as well. Okay, so that means any number can be plugged in for X, so our domain can be literally any number. So if I want to write that in interval notation, how do I do that? Interval notation, you always write your lowest thing it can be and then your highest thing it can be. And if it can be any low thing, our lowest thing is -infinity. Same thing on the high end is going to be +infinity. And that's how you'd write the domain in interval notation for literally any number imaginable except imaginary, but we'll get there later. Just to sketch a graph of this, and you may not know how to sketch this, which is totally fine. We learn this later. But since I do, I'm going to throw the sketch there. You can see why the domain is -infinity to infinity, because these will technically go on forever and ever and ever, getting increasingly wider because it's a parabola. So you're going to cover everything on the x-axis on the right or left sides. Range is a little bit trickier, I'm not going to lie. But once again, we can figure this out. Okay, so range is the set of all possible outputs. To figure out what the outputs are going to be, it's helpful to think of what you get when you plug in inputs. So take those same examples. When you square 1 plus 5, you're going to get 9. I'm sorry, you're not going to get 9. Whoa, you're going to get 6. I'm jumping ahead to my next example, which was to square 2. Okay, what if you plug in -1? -1 squared is still 1, plus 5 is still going to be 6. So whether you plug in a positive number or a negative number, you're going to get a positive number out of that. Okay, if you just think about x squared, the output of x squared is always going to be positive, because anything times itself is going to be a positive number. So what's the lowest thing that can come out of just x squared? Well, if you square 0, 0 times 0 is 0. So that's going to be the lowest thing that can come out of x squared. But then you're going to add 5 to it. So the lowest thing that can come out of this function then would be 5. That's your lower bound. And that's going to be included because you can get that as an output. Okay, so my range hint was to think about what's the lowest that y will ever be, which is what I just did. Then you're going to think about what the highest thing that y can be is. So let's say I plug in like 10. 10 squared is 100 plus 5. You're just going to get a big number. Let's say I put in 100. 100 squared is another big number plus 5. It's just going to be another big number. Or if you square a million squared plus 5 is just a really big number. So you see, we're going to get really, really high up all the way to positive infinity. Even if you plug in a negative big number, like -100 squared, that's still going to be positive plus 5 is still going to be a positive number. So the highest thing your range can be is infinity, which you'd throw a parenthesis on because it's a concept. Which you can see on the graph here. So range is talking about y values. So here's my y-axis. Here's the lowest thing y can be. And then these arrows continue forever and ever in the increasing direction. So you're just going to get really, really tall, and then all y values will be included. Okay, so if there's anything I can just kind of summarize here, it's that in order to find the domain and range, you are seeing me plug in values to test things until I know what the function is doing or what the function looks like or how it operates. So we'll just try one more together since I already started this. So I asked, is there anything x cannot be? We figured out that that thing was -3. If you plug that in, you divide by 0, that can't happen. So basically, for the domain of this function, we can have literally any number in the world except -3. So on the lowest bound, we can be at -infinity, but then it has to stop at -3 and not be included. But on the flip side also, we could go from -3 to positive infinity because we can have any big positive numbers. So that is actually the domain. You can kind of look at this on the number line as if it like is all of this, and then here's -3, and it just stops there, and then it keeps going into 2 separate intervals, which we usually put a U between to mean union, which just unites the 2 intervals. Okay. Oof, the range on this is a tricky one, so stay with me here. So I'm going to start by just plugging in a few values. So if I plug in like 10, you're going to get a small fraction because that's going to be 4/13. If I plug in 100, it would be an even smaller fraction because you're going to have 4/103. If I plug in a negative number, say it's like -2, right, we're going to have 4/1, so you get 4 out. We have numbers coming here. If I plug in a bigger negative number, you're just going to get a negative fraction. That's going to be 4/-7. So you can get out whole numbers, you can get out positive numbers, you can get out negative numbers, you can get out fractions. I want you to think really carefully about what you cannot get out of the range. My hint to you is that 4 is in the numerator. So if 4 is in the numerator, you're always going to have 4 over some number equaling your y value. What's the only thing you can't get out? Well, just as a reminder, if you have 4 divided by 1/3, that's the same thing as 4 times 3/1 by the reciprocal, which is 12. So you can get out big numbers. I oftentimes get people think that you can't, but you can. The only thing you can never get out of this is 0, because the only way to get 0 in a fraction is to have 0 divided by a number, and that's never going to happen because you have 4 in the numerator. So the range of this function is actually any number in the world except 0. So we would write it similarly to the domain, but it would stop at 0. And then it would continue after 0 all the way to infinity. And if you were curious, this is what the function looks like. Oops, where did that come from? Something we'll learn later, but you can compare that to the domain and range to see a visual. Otherwise, that's how you find domain and range from a graph and equations. Have a good rest of your night.